Hello everyone, and welcome back to another episode of Math with Dr. War. This lesson today is for my college students, and we're going to be simplifying rational expressions. I'm going to begin from the simplest and then move my way down to difficult. Let's begin. For rational expression, rational ratio means a fraction. Because it says expression, you have variables. So here I have z's and here I have x. Now, to simplify a rational expression, you're going to have to use factoring. So you must be able to perform Gcf factoring, difference of two squares, factoring a basic trinomial, and you never know, sometimes you may have to use the AC method. Let's try these first two problems. So I have 15z squared plus 25z divided by 10z minus 30. Now I notice that I have two terms in the numerator and the denominator. Whenever you see two terms, you're either doing Gcf factoring or the difference of two squares. Because 15 is not perfect, I know that this would be a Gcf factoring. I'll link at the end my factoring videos if you have trouble factoring, because you must know how to factor. If not, you're going to find these types of problems and problems further down in the semester very difficult. So I have 15z squared plus 25z. Now if I have to factor this, I look at my coefficients, 15 and 25. Both of these can be divided by 5, and we want the greatest factor that would divide them. And I see I have z squared and z, so you always take the one with the smallest exponent. So I'm factoring out 5z. So this becomes, I'm going to go down here, 5z, and when I divide, 15 divided by 5 is 3, z squared divided by z is z, plus 25 divided by 5 is 5, and the z squares cancel. So my numerator went from 15z squared plus 25z to 5z times 3z plus 5. Now I have my 10z minus 30. And I'm going to factor that. Now, looking at my coefficients, 10 and 30, both of these can be divided by 10. The z is only with the 10, so I can't factor it out because it's not with both terms. Therefore, my GCF is 10. And to get the middle, I'm just going to divide. So the 10s cancel each other out, leaving me with z minus, and 30 divided by 10 is 3. So my denominator is 10 times z minus 3. Our next step is to look to see where we can simplify. I see the 5 and the 10, and I know that both of these can be divided by 5. So I'm going to go ahead and divide them by 5. 5 divided by 5 is 1. So I'm just going to leave that as 1z. I'm not going to write the 1. And then I have 3z plus 5. Divided by 10 divided by 5 is 2, and this will just be 2 times z minus 3. And this is your answer. Now, some textbooks, they would leave their answer like this, and other times they don't like the parentheses. So they'll use the distribution rule. So let's distribute. Z times 3z would be 3z squared. Z times 5 would be 5z over 2 times z is 2z, minus 2 times 3 is 6. And you can leave your answer like this. It depends on your professor, and sometimes it depends on the textbook. So either of these answers are correct, either this one or this one. But again, it depends on your professor and also how the answers are written in your textbook. I have 4x squared plus 8x minus 60 divided by 6x squared plus 6x minus 72. Now here I have a trinomial because it's 3 terms. Whenever you have a trinomial, always try Gcf factoring first. So when I look here, I see 4, 8, and 60. All of these could be divided by 4. So if I factor out the 4, I'm going to be left with x squared plus 2x minus 15. Because remember, it's like you're just dividing each of these by 4. And 4 is your GCF. I have 6x squared plus 6x minus 72. Each of these terms, I can factor out 6. And I'm going to go ahead and do that, which would give me the 6, leaving me with x squared plus x minus 12. I noticed that with my trinomials, I need to factor those. So I have 4. I'm going to open up my parentheses. Now a trinomial, this is when you're going to have 2. So you have 2 parentheses if you have a trinomial or a difference of 2 squares. X squared would be x times x. My product is negative 15, which means that one would be a positive and the other would be negative. I am looking for 2 numbers that when I multiply, I get 15, but when I subtract, I get 2. So the 2 numbers that multiply to give me 15 is 5 times 3. If I subtract them, I get a 2. I want a positive 2. Therefore, the bigger number 5 would go with the plus sign and the 3 with the negative. Because when you're adding integers, we always keep the sign of the larger number. So because my answer here is a positive 2, the 5 would take the positive sign. X squared plus x minus 12. I have an x here and here. Notice I have a negative 12. The only way you can get a negative product is if you have a positive and a negative. I'm looking for 2 factors that when I multiply would give me 12. But when I subtract, I get a 1, and that would be 4 times 3. Now the 1 needs to be positive, therefore the 4, which is the bigger, will go with the plus and the 3 with the negative. And I would suggest you check your answers. 4 times negative 3 is negative 12, and if I combine 4 and negative 3, I would get a positive 1. Next, we're going to simplify. I notice these two x minus 3 will cancel each other out. The 4 and the 6 here are even numbers. Even numbers are divisible by 2, so I'm going to go ahead and divide each of these by 2. 4 divided by 2 is 2. Don't forget your x plus 5. 6 divided by 2 is 3, and you have your x plus 4. Again, depending on your professor, this is okay for me, but some people don't like the parentheses, so distribute. This will be 2x plus 10 over 3x plus 12. And you're finished. But remember, both of these are correct. It's up to your professor, whoever you have. For me, this is fine. Some people want you to distribute and get rid of the parentheses. Now here with my rational expressions, I'm adding them. If you look at your denominator, it's only one term. It's a monomial. Whenever you're adding or subtracting fractions, the first step is to find the lowest common denominator. So it's just like you're adding normal fractions, and when the denominators are different, you first have to find the LCD. So here I'm going to start with my coefficients. I have 6 and 4. What number would 4 and 6 divide evenly? And we want the lowest one, and that would be 12. Now, if you didn't know it was 12, I usually go for the greatest coefficient, which is 6, and then I write out the 6 times table just for like 3 to 4 terms. 6 times 1 is 6, 6 times 2 is 12, 6 times 3 is 18. Then I look to see which of these 4 would divide evenly. It's not going to divide the 6, but it will divide 12 evenly. So 12 is my LCD. When it comes to the variables, that is easy. Your LCD would be the variable with the greater exponent. Notice that both of them have A's. So you're going to choose the A with the greatest exponent, not the smallest, the greatest. Our next step is to make equivalent fractions. Here I have a 4, but I need to make a 12. Therefore, I need to times by 3. Here I have A, but I need A squared. So I need to multiply by an A. 5 times 3A is 15A. Now over here, I have a 6, but I need to make it 12. Therefore, I will have to times by 2. Here I have A squared, and here I have A squared, so you don't need an A squared. So we're just timesing the 1 by 2, which is 2. Remember, when the denominators are the same, we keep the denominator and we combine our numerators. Now your numerator is a variable and a constant. Now you can't actually combine them, so you can't actually add them. You're going to create a number sentence. So your answer is 15a plus 2. Always remember to check to see if you can factor your numerator. Here, 15 and 2, they don't have anything in common, so we're okay. I have 5 over xy plus 7 over 2x squared. So we have to find our LCD. Okay, here's your invisible 1. So you have 1 and 2, so of course your LCD for the coefficient is 2. I notice I have an x here, and over here I have an x squared. And remember, when it's your variables, choose the variable with the greatest exponent. So we're going to keep the x squared. I notice I have a y here, but nothing on this side, which means you're going to need that y. So you can't get rid of it. So your LCD is 2x squared y. Now here, I need to make this 1 a 2. Therefore, I have to times by 2. This x need to become an x squared, so we're actually missing an x. And notice this is y, and we already have y, so we don't need a y. So 2x times 5 is 10x. Okay, notice here I have a 2, and here I have a 2. Great. I have x squared and x squared. That is great. But remember, we need a 2x squared y, so this is actually missing a y. So you'll times by y. 7 times y is 7y. The denominators are the same, so we're going to keep the 2x squared y. We're going to create our number sentence, which is 10x plus 7y, and we're finished. Now, these rational expressions, notice the denominators are binomials. So we have to find the LCD just as before. So I'm just going to draw one line because this is going to become a little bit messy. So whenever I have a binomial, I think about a kid in a candy store. So you take a little kid to the candy store and you tell the little kid that you can only take one of each type of candy. So the kid goes in the candy store. He comes across n plus 7, so he's going to take that. So that's his first candy. And then he comes across n minus 2, so he's going to take that. And his journey in the candy store is over. Remember, he can only take one of each type of candy. This is your LCD. So I'm going to go back here. I have n plus 7, and your LCD is supposed to be n plus 7 times n minus 2. So I'm going to keep that 4, and I'm like, okay, I have the n plus 7, so who are you missing? This, the n minus 2. So I'm going to put that next to the 4, minus, write your 7. Okay, this has n minus 2 right here, so who are you missing? Yep, the n plus 7. And we're going to simplify this. Only the numerator, because you can't leave it like this. So when you distribute, you get 4n minus 8, negative 7n minus 49. And your denominator, you're going to keep that as n plus 7 and n minus 2. Please do not multiply it. Leave it like this in its factored form. We're going to simplify. So 4 minus 7n is negative 3n. And negative 8 minus 49 is negative 57. And all of that is over n plus 7 and the n minus 2. I have x minus 2 divided by x minus 6. And I'm subtracting x plus 2 over 6 minus x. Notice that this is the negation of this. So notice I have an x here, but this is a negative x. And here I have negative 6, and this is a positive 6. So to make it easier, I'm going to rewrite this to look like that. So this would be x minus 2 over x minus 6. And remember I said it's the negation. So here's my subtraction. This is x plus 2 over. So basically, you're going to have a negative sign, and it's going to be x minus 6. Because it's like you're factoring out the negative. So if you pull out the negative, the 6, which is positive, now becomes negative. And the x that was negative now becomes positive. And these two negatives turns into a plus sign. So this is now x minus 2 over x minus 6 plus x plus 2 over x minus 6. And notice we didn't even have to find the LCD. Our denominators are the same, which is your x minus 6. And when your denominators are the same, you just combine your numerators. So this will be x minus 2. Because this is a plus sign, I'm just going to bring that down. I'm going to combine my like terms. So x plus x will give me 2x. The negative 2 and the positive 2 eliminate each other to become 0. And my denominator is x minus 6. This is where it gets difficult. So here I have x minus 2 divided by 5x plus 25 plus 3x plus 1 divided by x squared minus 25. Now before you go about trying to find your LCD, your first step is you have to factor. Now when I look at my denominators, here I can do a GCF. I can factor out 5. And here, because this is x squared and it's perfect, and this is 25 and it's also perfect, and it's separated by subtraction, this will be the difference of 2 squares. So I have x minus 2 over, okay, here I'm going to factor out the 5, which would leave me with x plus 5. Over here I have 3x plus 1, and then this is dots. So this would be x plus and minus, and 25 is 5 times 5. So now that we have it in the factored form, we're going to go back to that kid in the candy store. So I'm going to draw a very long line, and here's your kid going in the candy store. So he's going to take 5. He's going to take x plus 5. Okay, he gets the x plus 5, but he can't take it again because he already has it. Remember, you can only take one unique candy. You can't have multiples of the same. So then here you have x minus 5. He doesn't have that, so he's going to take it. Now here I'm going to go with my x minus 2, like that. Now I'm going to look. Now right here, I have a 5 and an x plus 5. So I have this 5 and x plus 5. So who's missing? The x minus 5 plus, okay, I have my 3x plus 1. Okay, look at this. I have x plus 5 and x minus 5. This is my LCD. So I have this. Who am I missing? The 5. So now we have to simplify our numerator. So I have to multiply these two. I'm going to do this pretty quickly. You should be able to multiply binomials. This will be x squared minus 7x plus 10. Here's a little trick. X times x is x squared. Now the negatives 2 and the negative 5, you're going to find the sum of that. That's how I got negative 7. And then the negative 2 and the negative 5 is my product, which will give you positive 10. Multiply x and x to give you x squared. And then these two numbers, find the sum, boom. Find the product, boom. And then here, this is easy. You're just distributing. So 5 times 3x is 15x plus 5. And that's all over 5x plus 5 times x minus 5. Now we're going to have to combine our like terms. So in my numerator, I only have 1x squared, so I'm going to keep that. Now the negative 7x and the positive 15x would give me a positive 8x. Plus the 10 and the 5 is going to give me 15. And all of that is over 5, x plus 5, and x minus 5. Now because my numerator is a trinomial, I'm going to have to factor that. So x squared is x times x. Because all of these are positives, plus and plus. Now I'm looking for two numbers that multiply to give 15, and when you add, you get 8. You got it right, 5 and 3. And then your denominator is 5, x plus 5, x minus 5. And notice what happens. This x plus 5 cancels this x plus 5. So your answer is x plus 3 over 5 times x minus 5. If you want to, you can distribute that and write your answer as x plus 3 over 5x minus 25. But again, both of these are correct. Over here, I have 3 over x squared plus 7x plus 10, and I'm subtracting 4 over x squared plus 6x plus 5. I notice I have my trinomials, so you must factor. No one wants to work with a messy trinomial. So this would be 3 over, and I'm going to open my parentheses, minus 4, and I'm going to open my parentheses. X squared is x and x. They're all plus, so positive and positive, looking for two numbers that multiply to give 10, and when you add, you get 7, 5, and 2. Over here, x squared, you have x and x. All are positive, so they're all plus. I'm looking for two numbers that when I multiply, I get 5, and when I add, I get 6. That would be 1 and 5. So I have to find my LCD, so I want to draw this very long line. And kid in a candy store again. Okay, so the kid goes in, he's going to get x plus 5. Okay, he's going to get x plus 2. Okay, he's going to get x plus 1. And he came across x plus 5 again. So he can't take it because that will be a repeating type of candy. So your LCD is just the x plus 5, the x plus 2, and the x plus 1. I'm going to write my 3. Now here in my denominator, I have x plus 5 and x plus 2, which are these two. So I'm missing this one. So I'm going to put that next to the 3. Minus 4. Okay, here I have the x plus 1 and the x plus 5. So this and this one, you're missing this. That's going to be next to the 4. We're going to simplify the top. So that will be 3x plus 3 minus 4x minus 8. All of that over your x plus 5, x plus 2, and x plus 1. When we simplify some more, 3x minus 4x is negative x, and then 3 with the negative 8 is negative 5. And all of that is over your x plus 5, x plus 2, and your x plus 1. Now, whenever I see negatives leading with the variable, I'm always like, okay, let's factor it out. So if I factor out the negative, that would leave me with a positive x and a positive 5. Because it's like you're divided by negative 1. So if I divide this by negative 1, I'm going to get a positive x. And if I divide this by negative 1, I get a positive 5. And then my denominator is x plus 5, x plus 2, and x plus 1. And notice these two cancel each other out. So your answer is negative, and you must have a number here. So it'll be a negative 1. Okay, it's just not going to be just negative. Negative 1, because we have to have something in the numerator. And your denominator is going to be x plus 2 times x plus 1. And leave it like that. Do not multiply the denominator out back to a polynomial. So this is your answer. I hope this lesson has been helpful. Good luck in your class.